Welcome back to Chem Crash. Today in our third lesson of pre-organic chemistry, we're going to be covering hybridization. Last time we learned that atomic orbitals combine to form bonding orbitals, and we only discussed these in terms of similar orbitals. So for example, we talked about two s orbitals overlapping head to form a sigma bonding orbital. We also talked about two p orbitals overlapping head to form also a sigma bonding orbital. And we also talked about p orbitals parallel to each other, which overlap side to side to form a pi bonding orbital. Now, as you can see here, there are two different types of orbitals that can form sigma bonds. We have the s orbitals overlapping, and we have the p orbitals overlapping. There are many instances in which electrons are in both s and p orbitals, as indicated by electron configuration of certain atoms. And this means that both s sigma bonds and p sigma bonds form. When both s sigma bonds and p sigma bonds can form, they don't form two different bonds. They actually form a hybridized orbital. This would look like a mix of an s and a p orbital. So we have a p orbital that looks like this, and we have an s orbital that looks like this. When they hybridize, they turn out to something that might look like this, where we have a bigger side containing the s orbital, and the rest is the p orbital, representing the p orbital. Now, it would be really complicated to discuss how each molecule and each bond between atoms would hybridize. So there is an easier way to identify what the hybridization of an atom within a molecule might be. There are four main types of hybridization that we deal with in organic chemistry: S, sp, sp2, and sp3. So what we saw before, where we had both a p bond and a p sigma bond and an s sigma bond combining to form a hybridized orbital, this would be an example of sp. It's unnecessary to go through what the other hybridizations look like, so let's get into how we can identify the hybridizations for each molecule. The main thing you'll need to identify within an atom are the electron groups around it and the number of electron groups around it. So what are electron groups? Electron groups include lone pairs, single bonds, double bonds, and triple bonds. Each of these represent one electron group. One electron group, one electron group, one electron group. So even though an atom might have a double bond, like O double bonded with O, this is still considered one electron group. Same goes with triple bonds. Now, once we identify the number of electron groups, we can identify what hybridization it is. So an S hybridization would be if there was one electron group. An SP hybridization would be if there's two electron groups. sp2 would be 3 electron groups, and sp3 4 electron groups. This is easy to remember because S only has one orbital, sp has 2 orbitals, sp2 has 1 s orbital, 2 p orbitals, so that's 3 orbitals, and sp3 has 4 orbitals. So the number of electron groups corresponds to the number of orbitals that end up being hybridized, which corresponds to the hybridization of that atom. Let's do an example together. Here we have BeCl2. What we want to find is the hybridization of Be. So remember, hybridization does not correspond to an entire molecule. Hybridization corresponds to individual atoms within the molecule. So let's find the hybridization of Be. Let's first count the electron groups around Be. We have one single bond here, and we have one single bond here. So there's nothing else around it. There are no lone pairs, no other bonds. So we see that there are two electron groups. Let's figure out the hybridization. I want you to pause the video and click the bar at the top right of the screen and vote on what you think the hybridization is going to be. Alright, the hybridization of BeCl2 is sp. If we look back here, we know that there are two electron groups corresponds to sp hybridization. Perfect. Let's go on to another example. Bf3. So this question asks you to find the hybridization of B. We're going to again count the number of electron groups around B. There's one single bond here, another single bond here, and a third single bond here. So I count 3 electron groups around B. This means that it has what hybridization? Vote now. Alright, so B has sp2 hybridization. Again, if we look back here, we can see that 3 electron groups correspond to sp3 hybridization. This is the final example, CH4. So this question actually asks you two things. First, it asks you to find the hybridization of C, and next it asks you to find the hybridization of H. So first, we'll work with C. Let's count the number of electron groups around C. There's a single bond here, a single bond here, a single bond here, and a fourth single bond here. So in total, I count 4 electron groups. What do you think the hybridization is going to be? I want you to vote in the top right corner now. Thanks. The hybridization of C is sp3. If we look back here, we can see that 4 electron groups corresponds to an sp3 hybridization. Let's now do the hybridization of the H. All 4 H's here are the same in that they all have one single bond attached to each of them, which means that each hydrogen atom has 1 electron group. What do you think the hybridization of this hydrogen atom is? Please vote in the poll now. So the hybridization of H is S. If we look back here, 1 electron group corresponds to S hybridization. Let us now start talking about how we can use hybridization to name bonds. Because hybridization corresponds to each individual atom, but not the entire molecule. And so how can we use the hybridization to name the different bonds that are formed? First, let's review that a single bond corresponds to a sigma bond, and that a double bond corresponds to a pi bond and a sigma bond, and that a triple bond corresponds to 2 pi bonds and 1 sigma bond. This is the case always. Let's use an example to discuss how we're going to name the bond. Let's use CH4 from the previous example. We know the hybridization of each of these atoms. We know that C has a hybridization of sp3, and we know that each of the H's have a hybridization of S. Now we can name the bond. We see that it's a single bond, so we know that if we were to name the bond between this C and this H, that it would be a sigma bond, and that there would only be 1 bond. How do we name it? Well, very simply, we would name it an sp3s sigma bond, because it's between an sp3 carbon and an s hybridized hydrogen. So this would be called an sp3s sigma bond, and that applies to every bond around the C. So all the bonds in this molecule are sp3s sigma bonds. They're all exactly the same, and so we would write that there are 4 sp3s sigma bonds in this molecule. Let us now look at a more complicated example with a bigger molecule. The first step, and the most important step, is to find the hybridization for each atom within the molecule. Let's first find the hybridization of H. Because of the nature of H can only hold one electron group always. It can always only hold one electron group because it only has one electron. And so the hybridization of H, no matter where it is, no matter what it's bonded to, will always be S. There are 2 carbon molecules, so I named them C1 and C2. So first let's look at the hybridization of C1. C1 has a double bond with C2, which corresponds to 1 electron group, and 2 single bonds between 2 different hydrogens, which corresponds to 2 more electron groups. In total, that's 3 electron groups, giving it an sp2 hybridization. With C2 shares the double bond with C1, so that's 1 electron group, and C2 also has a double bond with a nitrogen, which corresponds to a 2nd electron group. 2 electron groups corresponds to an sp hybridization. The nitrogen also shares that double bond with C2 and has 3 separate single bonds with 3 different hydrogens, giving it a total of 4 electron groups and thus a hybridization of sp3. Now let's move on to naming the bonds. Between the H and C1, we can see that it is a single bond and that both bonds are going to be identical. So we'll write 2 times here, and we know that the H has an S hybridization and that the C has an sp2 hybridization, so it would be an ssp2 sigma bond, because single bonds are sigma bonds. Single bonds are sigma bonds. Now between C1 and C2, we see a double bond. An important thing to clarify is that hybridization occurs only between 2 different types of orbitals. So sigma bonds are hybridized because both s orbitals and p orbitals can form sigma bonds because they can both have head-to-head overlap. However, pi bonds from side-to-side overlap can only be formed by p orbitals. S orbitals cannot form a side-to-side overlap, and therefore only p orbitals can have a pi bond, and there's no hybridization with pi bonds. Let's see how that affects our bond naming. So we know that C1 is sp2 and C2 is sp, so we have an sp2 sp sigma bond. That's the first bond. The second bond in the double bond is a pi bond, but a pi bond cannot have hybridization. It can only be between p orbitals. So we have a p-p pi bond. Those are the 2 orbitals for C1 and C2 double bond. Now the C2N double bond, it will be the same thing except different hybridizations. So we know that C2 has an sp hybridization, and we know that N has an sp3 hybridization. So it would be an sp3 hybridized sigma bond and a pp pi bond like before. Finally, between the N and the H's, we know that there are 3 NH bonds and they're going to be identical. And we know that H is S hybridized and N is sp3 hybridized. So we're going to have an sp3. We're going to have 3 sp3s sigma bonds. There you have it. That is hybridization in a nutshell, and that's how you name bonds based on hybridization. Thanks for watching.